Good day all and welcome to my channel. This time we'll be looking at the concluding part of our chemistry videos on our revision of chemistry. For those that are writing Jamb 2023, this video is for you. Alright? So you just follow through this series of questions as I run through and then explain exhaustively some aspects that are very vital that you might see in your exam. Alright? So let's run through the series without wasting much time. Looking at the board, we are having 10 questions. I believe that we are going to be having more than 10 questions in this series. Alright? So let's just finish up with these 10 questions and then we'll move on to the next. On the board, question 1. Which class of organic compound has a fishy smell? Which class of organic compound has a fishy smell? When we talk about organic compounds that has fishy smells, we are referring to the amines. The amines. Now, the amines are organic compounds present in organic chemistry 2. Organic chemistry is broken into two parts. We have the organic chemistry 1 and the organic chemistry 2. So this is an organic chemistry 2 compound and it has a general formula RONH2, meaning that it contains the amino functional group. So in a case where you are asked which of the following organic compounds has its functional group to be the amino functional group only, that is actually what the amines. All right. For amino acids, they have a general structure COOH, then H, then R, then NH2. So for amino acids, they are known to have two functional groups. That is the amino functional group NH2 and the carboxylic functional group COOH. Then we still have other compounds like the amides. Now the amides, they are known to have a general formula RCONH2. So never should you mistake the amides for the amines. Alright? So the amines are known to have RONH2, while the amides are known to have RCONH2. Like I said, the only organic compounds that are generally known or characterized by their fishy smell is the amines. Alright? And one more thing that you need to know is that for the carboxylic group of the carboxylic acids present in organic chemistry 2, we have the general formula to be RCOOH. So this is for carboxylic acids. Carboxylic acids. Alright? Carboxylic acids are also called alkanoic acids. So take note of that. Alkanoic acids, carboxylic acids, they are same things. Alright? So these are organic chemistry 2 compounds. We still have the alkanals. Now the alkanals, they have a general formula RCHO. Then while the alkanones, they have a general formula RCOR. Then while that of the alkoxy alkanes, ethers, these ones they are also called alkoxy alkanes. They have a general formula ROR. Alright, so take cognizance of this, very important. So the correct answer to this question is option D. Remember I said that this one, I've even explained it there, that is the ethers, the alkoxy alkanes. Then while this one, I didn't really include it. These ones are called the esters. The esters. The esters are also called the alkanoids. Alkanoids, alright? So they have a general formula RCOOR. So that is their general formula. So these ones, they are the esters. These ones, they are the ethers. Then while this one is the amines, while this one is the amides. Alright? So take cognizance of that. So the correct answer is option D. Option D. Then number 2. Dash decolorizes bromine water. Dash decolorizes bromine water. Bromine water is one of the reagents that is used to test for unsaturation. In organic chemistry, we have 3 aliphatic hydrocarbons that are known as alkanes, and alkynes. These are aliphatic. You know, the aromatic is obvious, is the benzene and its derivatives. These ones, they are known to be saturated because they are characterized by their carbon-to-carbon single bond. Then while this one, they are known to be unsaturated because they are characterized by carbon-to-carbon double bonds. Then while the alkynes, they are also unsaturated because they are characterized by carbon-to-carbon triple bonds. So amongst these three, only two are unsaturated, alkenes and what? Alkynes. Then while alkenes are saturated. So it is these two compounds that can give positive test to bromine water, and to KMNO4 solution. KMNO4 solution. So what happens is this: when you react any member of the alkene with bromine water, it tends to decolorize bromine water. It decolorizes bromine water, alright? And same with this one, that's the KMNO4 solution. So both solutions, they get decolorized when treated with any member of the alkenes because the alkenes are unsaturated. Then for the alkynes, it's the same thing too. The alkynes, when they react with bromine water and KMNO4 solution, they also decolorize the solutions. Why? Because they are also unsaturated. But only the alkenes would not do that. Why? Because the alkenes are saturated. Alright? So looking at the question, dash decolorizes bromine water. See, they came in the form of formula: C2H6, C3H8, C2H4, C4H10. Now, let me quickly explain the formula of alkanes, and alkynes. Alkanes are known by their general formula CnH2n plus 2. Then while alkenes are known to have a general formula CnH2n. Then alkynes are known to have a general formula CnH2n minus 2. Alright, N here across board represents number of carbon atoms. Alright, so looking at the members of the alkanes, now we have the first member of the alkane to be methane, and methane is known to have a formula CH4. This is methane. Then the next member is C2H6, ethane. So while this one is methane, then this one is ethane. Alright, then C3H8 is propane, the third member of the alkanes. Then C4H10 is butane, that's the fourth member. And how did I come about this their formula? Of course, each successive members of a homologous series differs by CH2. So it means that successively you'll be increasing the carbons by 1 and the hydrogens by 2. So that's the reason why you see that 4, 6, 8, 10 by 2. Then 1, 2, 3, 4 by 1, you get. So those are the members of the alkenes. And if you check, we have, I think you have C2H6 there, a member of the alkane. So this is wrong because alkanes would not decolorize bromine water, remember. Then do we have C3H8? Of course, yes. So that's wrong. Do we have C4H10? Of course, yes. So it means the correct answer is C. And C is a member of the alkenes. Now, the formula there in C is C2H4. C2H4 is a member of the alkenes called ethene, or you can call it ethylene. Now, remember that I said that the general formula of the alkenes is CnH2n. So, N represents number of what? Carbon atoms. So, the number of carbon atoms of ethene is actually 2. So, N is equal to 2. So if we substitute it in this formula, which is CnH2n, then we'll be having C2H2 times 2, meaning 2, 2. So that gives us C2H4. So this is the formula of ethene, and you can simply get it from even ethane. You know that alkanes gives rise to alkenes upon the loss of 2 hydrogen atoms. So if I want to get a corresponding member of alkenes, all I will just simply do is that I will work with a member of the alkane. Now look at ethane. Ethane has the formula C2H6. So if I want to get a corresponding member of alkenes, which is from ethane, it will be ethene. And ethene will have to lose 2 hydrogens from ethane in order to get the formula. That becomes C2. When you take 2 away from 6, you are left with H4. So that's how you form the members of the alkenes. So the answer is C. Question 3. Looking at that, we are given an equation: 2H2 gas plus O2 gas, then to give 2H2O gas. Now looking at this reaction, from my lessons on Geluxa's law of combining volumes, you can understand the concept very well. But let me explain. Now, what are the mole ratios? We are having 2:1:2, meaning the numbers in front. Then we are given the volume of hydrogen to be 50 cm cube, and we are given the volume of oxygen to be 75. So this one is 50 cm cube was provided and 75 cm cube was provided of oxygen. We are not given any volume. So at the start of the reaction, there were no volumes of water. Now during the reaction, what will react? Look at this. This is the secret. Use the gas with the lower volume as your standard. How? Now looking at hydrogen gas, the mole ratio is 2. Its volume is 50. So it means 2 of hydrogen occupies 50 cm cube of volume. Then look at this one. 1 of oxygen occupies 75 cm cube of oxygen. So which do you think is bigger and which do you think is smaller? Of course, it's obvious that the hydrogen gas here is smaller because 2 of it is 50. Then while 1 of this is equivalent to 75. So that's to show that this is bigger. So what did I say? You use the lower volume that's of the gas as your standard. So which one should be reacting? The lower volume being the standard. So 50 is needed to carry out the reaction, and 50, which is 2 of this, needs 1 of itself to completely react with oxygen, and that becomes 50. 1 of 50 would be 25, because it's just like you saying that 2 of hydrogen needs 1 of oxygen to produce 2 of water. Then looking at this now, if you check, we have 50 cm cube of this hydrogen, and of course it's equivalent to these 2. So it only needs 1 of oxygen of that volume that it contains or occupies. So it means it is 25 that it needs of oxygen, so as for it to completely react. All right. So when it reacts, then you would no longer be left with any volume here. This would be 0 cm cube. Then of course this would be, when you subtract, you'll be left with 50 cm cube. So the excess gas that will be left unreacted of oxygen is 50 cm cube. Of course, at the product, you are still going to be having 50 cm cube based on the mole ratios, ratio 2 to 2. All right. So the answer is 50 cm cube. Then question 4. We are given an equation of zinc plus 2HCl to give ZnCl2 plus H2. Now looking at this, we are asked the question, zinc is the reducing agent, which is, of course, this question is very, very easy. Reducing agents are agents that are usually oxidized at the end of a redox reaction. Then while oxidizing agents are agents that are usually reduced at the end of a redox reaction. So of course, the answer to this question is A. So zinc was oxidized, meaning that it is the reducing agent. Question 5. The percentage of carbon, hydrogen, and oxygen are 75.46%, 4.43%, and 20.10% respectively. Calculate the empirical formula. So how do we calculate empirical formula? It's very easy for you to calculate empirical formula. The first thing you have to do is you bring out all the elements, talking about carbon, talking about hydrogen, and oxygen. Then the next, you represent their percentage compositions. Carbon is obvious, is 75.46, so 75.46. Then hydrogen is 4.43. Then oxygen is 20.10. Then the first step is to divide all through with their relative atomic masses. The relative atomic mass of carbon is 12, for hydrogen is 1, for oxygen is 16. So when you carry out the division, you'll be having, with the help of our calculator, 75.46 divided by 12. That gives us 6.29. Then this is obvious, is 4.43. Then 20.10 divided by 16. That gives us 1.26. So we'll now divide all through by the smallest value, and that's 1.26. So it becomes 1.26 over 1.26 over 1.26. And of course, this is obvious, is 1. Then while that of 4.43 divided by 1.26. So that gives us, we have 3.5 working with one decimal place. Then 6.29 divided by 1.26. That gives us 4.9. So looking at that, we can actually try to approximate this. But when you try to approximate this and you try to approximate this, it would end up giving you a wrong value. Do you know the reason why? Because in empirical formula determination, there are numbers that you are not supposed to approximate from 0.3, please take note of this, to 0.7, meaning when you are having any range of values from 0.3, 0.4, 0.5, 0.6, 0.7, don't approximate when you are having it at the end result. So what you do is this: for you to now convert it to a number that you can approximate, meaning 0.2 can be approximated, 0.1, 0.0, 0.8, 0.9, meaning you can round off. You know, in mathematics, 5 to 9 are numbers I can approximate. Then 0 to 4 are numbers I cannot approximate. So you can round off this one, and you can round off this one. You can round off this, and this as well. You get it? So now looking at that, we have 4.9, 3.5. Since there is 3.5, the 0.5 is in this range. So it means the first thing you have to do is to multiply all through by 2. You try it with 2 to see whether it's going to give you something that you can approximate. So 4.9 times 2, that gives 9.8. So this is 9.8. Then 3.5, that should be 7 times 2, that's 7. Then while this one is 2. So this is obvious that you can easily approximate this to 10. And 7, 10, 2. So bringing the empirical formula out from this, it becomes C10H7 then O2. So that's the empirical formula. All right, so just take your time to go through this series so as for you to get it very well. Next question. Question 6. Now we are given a reaction N2O4 gas, a reversible reaction of 2NO2 gas. All right, now we are giving our delta H to be negative 92 kilojoules per mole. The condition that will favor the production of N2O4 is, now this is coming under chemical equilibrium, and that's a very important topic in the world of chemistry that you need to understand. When we say chemical equilibrium, we are simply referring to a reversible reaction that occurs usually in a closed system. So this is a reversible reaction having a symbol, which is this. And of course, it's proceeding in two directions, the forward and the backward. Sometimes a system at equilibrium or balance has the tendency of losing its equilibrium. So when a system loses its equilibrium due to rapid changes in temperature, pressure, and concentration, according to the Le Chatelier's principle, what happens is this: the system tends to adjust itself in order to regain its equilibrium. So that's why you notice that they will be working with words like equilibrium position shifts to the right or equilibrium position shifts to the left. the system is trying to regain what? Equilibrium in that process. So looking at this reaction, they said what should favor this part? Okay, we are giving the delta H value here to be negative. And when you are giving your delta H value to be negative, it means that the forward reaction is an exothermic reaction. Then automatically the backward is endothermic. As me here was positive, then the forward would have been endothermic while the backward would have been exothermic. You understand? So now, what will favor this part? For every endothermic reaction, endothermic reactions, there are reactions that simply love heat. So there are reactions that absorb heat from their surrounding. You get? So they love heat. Then while exothermic, they release heat to the surrounding. So these ones, they release heat to the surrounding, while endothermic, they love heat. Alright? So what would favor the forward reaction being exo is decrease in temperature, because if the environment, the surrounding, experiences a drop in temperature, it can actually favor exothermic, but exothermic reactions do not love heat. Then while endothermic, they love heat. So when you increase the temperature of the surrounding, endothermic reactions are usually happy. Alright, so we want to look at what should favor this, meaning we have to move the equilibrium position to the left, and you cannot you cannot reduce temperature to favor this part. Why? Because the backward reaction here is what? Endo. And an increase in temperature favors endothermic, while a decrease in temperature favors exothermic. So it means first, for it to favor this part, there must be an increase in temperature, because this backward reaction is endo. Then next, we are also giving pressure. Looking at pressure, because they paired pressure and temperature in the options. How do we now dissect this? Now, for pressure, pressure only affects reactions that obey two principles. And what are the two principles? Number one, the reaction must have at least a gaseous species. That's one. It must not necessarily mean that all of them must be in the gaseous phase of matter. If there is at least one gas in the reaction, then it has obeyed that principle. Then the second principle, the reaction must have unequal gaseous volumes at both ends of the reaction. Okay, now look at this reaction. They are gases in obedience to the first one. Then what about the second? Do they have unequal gaseous volumes? Of course, yes. This happens to be one volume of this gas. Then while at this end, you have two volumes. So that's to show that they have unequal gaseous volumes. So since this reaction obeys the two principles, then it's obvious that it can be affected by changes in pressure. The hint is this. Boyle's law says that the volume of a given mass of gas is inversely proportional to its pressure, provided the temperature remains constant. So it means pressure is inversely proportional to volume, as well as volume is inversely proportional to pressure. So what does this mean? An increase in pressure will favor the part of the reaction with the smaller volume, while a decrease in pressure will favor the part of the reaction with the higher volume. Why? Because pressure and volume, they have inverse relationship. So an increase in pressure should favor a decrease in volume, while a decrease in pressure should favor an increase in volume. You get the point? So which one has the higher volume? Of course, this one. So what should favor this in terms of pressure? That should be what? A decrease in pressure, because this is the higher volume, while this one is the lower volume. So a decrease in pressure will favor the forward reaction here to produce more of this. Then while an increase in pressure will favor the backward to produce more of this. So it means that firstly, since the backward is endothermic, we have increase in temperature. And are we reducing pressure to favor the same part? No. We are also what? Increasing pressure. But when you increase pressure, it favors the part with the smaller volume. So an increase in temperature as well as an increase in pressure. So the correct answer is high temperature and high pressure, which is option C. Alright, so that's that about that. Then number 8. Dehydration of CH3, CH2, CH2, CH2OH. When you dehydrate, you use concentrated sulfuric acid to carry out the dehydration, meaning you want to remove water molecule. So if I bring this out, I want to represent based on structure for simplicity purpose. Still have more, one more, there's H then OH and H. All right. So we are having 1, 2, 3, 4. So looking at this, you notice that this is for this, this is for this, this is for this, and CH2 for this, and the OH. So if you want to remove what's it called, OH, what do? We can decide to just change the position for simplicity purpose, so as for you to understand it. So using concentrated sulfuric acid, H2SO4, we can take off this, and when we remove it, we have removed what? Water molecule. Then there will not be the formation of a bond there. So taking off this will lead to a formation of a bond. At the end, we are now going to be having CH, H, then CH, then C double bond C, H, and H. Now the name of this compound is but1ene. But1ene. How? We number backward because we want to give priority to these double bonds. And when you do that, between 1 and 2, we go with 1. And you're having 4 carbons there, that's but. And since you're having double bonds, that's but1ene. We went with the 1, being that is the lower one. Or you can simply call this butene. It's the same thing. Alright? So the dehydration of this will yield butene. And this is actually known as butanol. Alright? So that's butanol. Then number 9, the volume of a gas at 0 degrees Celsius is 29.5 cm3. Find the volume when the temperature is 15 degrees Celsius at a constant pressure. Now, Boyle's law, Charles' law, and pressure law. Pressure law is also called Hamilton's law. Alright? Now, Boyle's law, what is constant is temperature. So temperature is constant in Boyle's law. Then in Charles' law, what is constant is pressure. So pressure is constant in Charles' law. Then in pressure law, volume is constant. Alright? So looking at the formula for calculating Boyle's law, is giving us P1V1 equal to P2V2. This is for Boyle's law. Then for Charles' law, it is giving us V1 over T1 equal to V2 over T2. This is Charles' law. Then for pressure law, is giving us P1 over T1 equal to P2 over T2. This one is for pressure law or Hamilton's law. Alright? So that is that about that. Then let's see how we can actually solve this question. Since volume, we are told to find volume when our temperature is this at constant pressure. So it's obvious that this question is coming from Charles' law. So let's go. The formula for Charles' law still remains V1 over T1 equal to V2 over T2. Let's bring out all the parameters. The volume of a gas at 0 degrees Celsius, meaning our T1 is 0 degrees Celsius, and our volume 1, V1, is 29.5 cm3. Then they said we should find V2, find volume when temperature is, so this is unknown, then temperature is 15 degrees Celsius. So we are told to find our V2. But meanwhile, we have to convert the temperatures to Kelvin. And by doing that, you add 273. So when you add 273 to this, is 273 Kelvin as our T1. Then for T2 is 15 plus 273. That becomes that should be okay. This is 8. This is 8. Then this is 2. So it's 288 Kelvin. All right. So when we plunge in those parameters, it becomes V1 is 29.5 over T1 is 273 equal to V2 is unknown. You can put X there. Then T2 is 288. So when we cross multiply with the help of our calculator, we have 288 times 29.5 then divided by, we have 273. So we have 31.12. So our X is 31.12. Our volume is in cm cube. So you go with that. So that's the answer to that question. All right. Then question 10. Question 10. Ethanol reacts with sodium to liberate. Remember that ethanol has a formula C2H5OH. So this is ethanol formed from ethane. Remember that we said ethane is C2H6. So if alkanes lose one hydrogen and that hydrogen that was lost is being replaced by OH, then it forms a corresponding member of the alkanols. So ethane being this one. So if I want to get ethanol, that's by removing the E and replacing with OL, then I would need to remove one H from here and replace with what? OH. At the end, I would obtain that. All right. So if I carry out a reaction of ethanol with sodium, it ends up giving me C2H5 then ONA plus H2. So balancing the reaction, here will be 2, and of course that's two hydrogens, and the whole of this will be affected again by the 2, and of course we now have 2 Na. So everything is balanced. All right. So this is ethanol, and this is sodium, and this is sodium ethoxide, while this is hydrogen gas. All right. So which of the following is produced or liberated as a gas? Of course is B. So it still works for all of the alkanols. All right. It works for all of the alkanols, not only ethanol. Still have propanol, butanol, and the rest of them. So it works. So this will be the first part of this series. Then let's see the second part of the series. Welcome to the next part of this video lesson. Now looking at question 11, the constituent of brass actually is an alloy. It's an alloy, and it is made up of a base metal called copper and zinc. Please never should you mistake brass for bronze. Bronze is still another alloy, and it is made up of copper and tin. So copper is the common element to bronze and brass. Then while the discrepancy is seen in the other elements, while brass is zinc, then bronze is tin. All right. So question 12, which of the following metals exhibits allotropy? We know what allotropy is. A phenomenon in which an element exists in various forms but having the same physical state. And of course, the only metal that exhibits allotropy is tin. We know that carbon exhibits allotropy, sulfur exhibits allotropy, then neon doesn't exhibit allotropy. But then again, these two, they happen to be non-metals. So the only metal that exhibits allotropy is tin. Then number 13, which of the following is a mixture? Which of the following is a mixture? Now, we have the classes of matter to be elements, compounds, and mixtures. And mixtures are generally known to be made up of two or more constituents that are physically combined together, meaning they can easily be separated by physical methods. And of course, they do not have definite formula. Hence, mixtures are collectively known as solutions. So the only mixture here is blood, because sand, pure sand, has a formula, and the formula is SiO2, silicon oxide. All right, and that is actually a compound. Then soap is an organic compound that comes in the form of either RCOONA or RCOOK. So it's an organic compound. Then water is, of course, a compound which is having the formula H2O. All right, so that's about that. Then looking at question 14, during electrolysis, what occurs at the anode? Remember that the terminologies associated with electrolysis, we have electrolytes, we have electrodes. Now, electrolytes are simply compounds that conduct electricity and are decomposed in the process. So if I say Na and NaCl, this is a metal, sodium metal. This is sodium chloride, a compound that conducts electricity. So you can call this an electrolyte, then while this one a conductor. So when an element conducts electricity, it's called the conductor. Then when a compound conducts electricity, it's called an electrolyte. Then looking at electrodes. Electrodes are materials in the form of wires, rods, or plates in which current enters or leaves the electrolyte. Alright, and we have two kinds of electrodes. We have the anode and we have the cathode. Now the anode is the positively charged electrode and the cathode is the negatively charged electrode. So what occurs at the anode is oxidation. Then what occurs at the cathode is reduction. So in case you come across a question like that, please go with oxidation as the reaction that occurs at the anode. Then question 15. The complete combustion of methane releases. The complete combustion of methane releases. Now listen, when we say complete combustion, we are referring to the combustion of an hydrocarbon. Methane happens to be an hydrocarbon under the members of the alkanes. That's the formula CH4. So when you combust methane, you know that the constituent of air that supports burning or combustion is oxygen. So if I say CH4 plus O2, complete combustion releases CO2 and H2O. Yes. Now when we want to balance this reaction, this is one carbon, one carbon. That's 4 hydrogens. Here is 2, so you have to make it 2. 2 times 2 is 4 hydrogens. The oxygen here is 2, over here is 2, then here 2. Total is 4 here, so you have to make here 2. Everything is balanced. But for those students that do not know how to balance reactions, especially on combustion reactions of organic compounds, there is a combustion equation that will be of help, and it's given as CXHY then plus X plus Y over 4 O2 to give XCO2 plus Y over 2 H2O. Alright, so this formula can be of help. X represents number of carbon atoms. Then Y represents number of hydrogen atoms. Alright, so we can use this formula to get the same balanced reaction. So let me show you how it is being applied. So in methane, how many carbons are we having there? 1. So our X in methane will be 1, and our Y is number of hydrogens, don't forget, and in methane is what? 4. So anywhere you just see X there, you put 1. Anywhere you see Y, you place 4 there. So that becomes C. No need to write 1 there because, of course, it's just 1 carbon. Then 4 plus, then 1 plus 4 over 4 O2. Then to give, you don't need to write 1 here now, because it's obvious it's still 1. Then plus 4 over 2 H2O. So 2 into 4 is 2. Then 4 into itself is 1. So that becomes CH4 plus 1 plus 1 is 2 O2 to give CO2 plus 2 H2O. So the reaction is balanced. If you compare this to this, they are the same. Yes. So this is balanced. So this is a balanced reaction. So you can try to memorize this equation because it will also be of help to those students that are battling with balancing of reactions, especially for organics. So this only works for organic chemistry 1. The alkanes, and the alkynes. Alkenes, and alkynes. It doesn't work for organic chemistry 2 compounds. Only organic chemistry 1, and more specifically to the aliphatic, being the alkenes, and the alkynes. Alright, so try to know this thing very well, and it's my hope that you've been able to learn 1 or 2 stuff in this video. Don't forget to like the video, place your comment, share the video, and don't forget to subscribe to this channel to get the very best from this channel. So it's my wish and my hope that everyone that has watched this video will come out successful in the forthcoming Jamb. Alright, thanks for watching and God bless.